So the area of this curve in general will be the integral from a to b of the difference f minus g if f is larger than g. Okay, that is the idea. And let us play with a simple example. Example 1 here. Yeah, you can see here the area of f and g when f is larger than g would be the sum of these two guys. Okay. And now the first example, find the area of the region bounded by the curve y is equal to e to the x and the curve y is equal to x. And the limit is when x from 0 to 1. So when you plot the two curves, we see that the area we are computing is this guy, right? Here. From the formula above, the area of this guy will be integral from 0 to 1, right, of the difference of fx minus gx, where fx is e to the x minus gx is x, right? Dx. So it is a definite integral. In order to do so, we need to find the antiderivative of these two guys, right? So can you help me with this? Very good. Antiderivative of e to the x is e to the x. Perfect. And very good. 1/2 of x squared, right? Thank you, Michael, right? Matthew, yeah. Thank you, Matthew. So, and the limit will run from x is equal to 0 to x is equal to 1. Okay? So, when we evaluate this value, what do we have? Gary, help me, please. Yes, e to the x when x is equal to the upper limit, right? Yes. Very good. Yeah, 0. Very good. 0 squared. I just want to write it explicitly, okay? Be careful. We should write this in the parentheses. Otherwise, you may got a mistake in the sign, right? Just be careful with that. Very good. So now e to the 1 is e. And here is 1/2. Very good. In front of that is a positive sign, so we can remove the parentheses. But this guy, e to the 0 is 1. And we want to get rid of the parentheses here. We need to change the sign, right? 1 then becomes a -1. And this guy is 0, then we're good. So we simplify it. It becomes e minus, yeah, 3/2. Very good. Okay, very good. Is there any question? Okay, then there's nothing new, right? So let us continue. In general, the area bounded by the lower limit A and the upper limit B, and the two curve, we call it y top and y bottom, is in this figure here, will give us the area of this region. Or in general, if you want to compute the area formed by two curves, F and G, where there are some intersection between these two lines, right? From A to B, then what we need to do is to compute the area formed by the lower limit to the first intersection. If suppose they have two intersections, right? And the next area will be from the first intersection to the second intersection here. And then from the second intersection to the upper limit. So we will compute S1, S2, and S3. Okay? According to this figure, so suppose we call it C and D. And the curve Y, the blue curve here is the curve Y is equal to G of X. The red curve here is the curve Y is equal to F of X. From the interval from A to C, which one is larger, F or G? Yeah, F is larger than G in this interval, right? The second interval, which one is larger? Very good. G is larger in the second interval. And in the third interval, which one is larger? Yes, F is larger. So it means that our job is to determine on each intervals, right, which one is larger. Then our job is to integrate from this region, right? C to D, and then integral from D to B, right? And remember, the integrand will be the difference of the larger one minus the lower one, smaller one. In general, we can write it as the integral from the interval from A to B of absolute value of F minus G. Okay? That is the general formula for this. And the absolute value here is very annoying. So what we need to do is to determine the interval where F is larger than G, right? And the intervals where G is larger than F. So we can get rid of the absolute value. Okay? So let us play with this example. Okay? Find the area of the region enclosed by the parabolas y is equal to x squared and y is 2x minus x squared. So if we define the function f is x squared and the function g is 2x minus x squared, Then let us consider the function h of x. Let us define is the difference of f and g. Okay. If we do it this way, our job is to determine the intersection, and then from which intervals they are positive or negative. Okay. In other words, we need to find the solution of the function f minus g is equal to 0. Is the idea clear? Okay. We need to find the intersections. Okay. Now we substitute f here and g. We will have x squared minus 2x minus x squared here, which give us 2x squared minus 2x. And we should be very careful right here. Okay, let me write it down below. We are solving 2x squared minus 2x is equal to 0, right? This is the function h or f minus g. Some people will solve it this way. 2x squared, eliminate the 2x here by adding 2x to both sides. Then divide both sides by 2x, which gives us x, and equal to 1. What is missing here? Very good. We missed a solution at 0. Is it Josh or Andre? Thank you, Josh. You did a good job in the previous test. And so do you see that? So be careful here. Don't get mistake next time. Because here, if we do it this way, we factor it out, it will be the product of 2 times x minus 1 equal to 0. And the solution will be, there are 2 possibilities. This guy is equal to 0 or x is equal to 0, or the second guy is equal to 0, right? Or x is equal to 1. So in fact, there are 2 solutions here. Okay? Is it clear? So now we found 2 intersections, right? And let us study the function h of x, which is the difference of f and g, from x is equal to 0 to x is equal to 1. Or in general, we can study it in the whole real lines, from negative infinity to 0 to 1 and infinity, right? For the function 2x here, the solution will be at 0. Very good. And for any numbers which is smaller than 0, the sign of 2x will be negative. Thank you, Matthew. The same story. We study the function x minus 1 here. What is the solution of this guy? Very good. And the number is smaller than 1, it will have negative sign. Very good. So in general, the product of these two give us the function h or the difference of f minus g, right? Sorry? The same thing. because h is f minus g, right? Very good. Then negative times negative, the product of these two give us a positive and negative, and then positive. Okay? What does it mean? Very good. In the interval from negative to 0, the difference of this is positive. It means f is larger than g. And from 0 to 1, very good. The difference is negative, therefore g is larger than f. And from 1 to infinity, good job. That's it. Okay. Do you have any question up to here? Hmm?
Does it depend on, like, say if G is longer than F, do we subtract F from G for the equation?
Yes, very good. So because now let us draw the function f and g on the graph and see together, okay? Let us do it first. So the function f is x squared. You can, yeah, as you studied before in section previous chapter, you can draw it easily. It will be a curve at 2, it would be 4. It would be this curve, the function f. And here, 2x minus x squared, it will have the shape of this guy. Look at this guy. It has a solution x here and 2 minus x. Therefore, there are two solutions at 0 and at 2, right? So if this is 1, this is 2, then here the graph let me draw a bigger graph. You see it better. Sorry about this. If it is 1, this is 1, then this is 2. Yeah. This is x squared for the function f. And this guy is the function g. Okay. And the intersection is at 0 and 1. As you can see that the solution of the difference here, right? Or the position where f is equal to g is at 0 and 1. These are the intersection points. And we see that it makes sense. From 0 to 1, f is larger than g, right? F is on top of g here. Makes sense with the table here. Okay? And the area formed by these curves is this area. Okay? And you can do it from the formula. It is the integral from 0 to 1 of the difference of f minus g of x dx. Okay? And our job is to compute this integral. In order to do so, we need to get rid of the absolute value, absolute sign, which means we need to determine which one is larger so that we can apply this one here, right? If we know f is larger than g, then the absolute value of f minus g will be f minus g. Or in our case here, g is larger than f, then this integral becomes integral from 0 to 1 of very good. Thank you, Matthew. So, is it clear enough? This is the reason why we need to compute this table. Okay? If we know the table here, we determine which one is larger, then we can get rid of the absolute value. Because we need to, the question here is to find the area of the region enclosed by the parabola, right? Therefore, we need to find the intersection. Yeah, from 0, 1. That is why we take the integral from 0 to 1. Okay. So now we know f and we know g already. We just substitute the value, right? And you can see this in the notes I gave you. Yeah, let us do it here. Then it will be integral from 0 to 1 of g is 2 minus 2x squared, right? 2x minus x squared. And the function f is x squared dx, okay? Now it becomes easier, right? So what should we do now? Here.
Cancel like terms.
Very good. Let us try to cancel like term. Integral from 0 to 1. This is the power of 1. So it will be itself here. This is
Or add
negative.
like term.
Yeah. Then we add like term here. There are 2x squared dx, right? So this is a definite integral. We need to find the antiderivative of each of these two guys. So what do we have? The constant, we write it here, right? The power of here is 1, then the antiderivative of that would be this power plus 1, which is 2. Then we need to divide it by this power, right? Which is 2. The same story here. The negative 2, we just rewrite it. And here is x squared. Antiderivative of x squared gives us x cubed. But then we need to eliminate the power here by dividing by 3. Okay. And the upper limit and lower limit are at x is equal to 0 to x is equal to 1. Okay. So what do we have here? Vikram, help me. Or let us simplify it first, right? 2 cancel with 2 give us x squared. Very good. From x is equal to 0 to 1. Which means it will be very good. Okay, good job. Thank you. So this guy is simply 0. Good job. Then this is 1 minus 2/3, right? Then they do not have the same denominator. So we can make them have the same denominator. It gives us 1/3. Okay. Is the idea clear now? Jenny? Sorry? Yeah, this is the area of the region here. Yeah. And that is also the answer of this problems. Okay. So let us summarize. So in order to find the area of this, we need to determine the lower bound, lower limit, and upper limit, right? Formed by these two curves, which mean we need to find the position where f is equal to g, or the same story, f minus g is equal to 0. So then we determine in each intervals here whether f is larger than g or g is larger than f. And yeah, this from the formula, this is the integral of from 0 to 1. Okay. Then we can eliminate the absolute sign here and write it as g minus f and compute the integral easily. So is the process clear now? Good job. So this is a second example. Okay. Find the area of the region bounded by the curve y is equal to sine x and y is equal to cosine x here. If we define the first one is f, the second one is g, the region in this from 0 to pi over 2, right? If we draw a graph of these two functions, we know that there is an intersection point here at pi is equal to 4, okay? So therefore, from formula, we know that the integral formed by f and g will be integral from 0 to this, the absolute value of f minus g dx, right? Okay, where f is sine and g is cosine. So from the picture here, can we separate the integral from 0 to pi over 2 into the sums of two integral? And what is it? Perfect. 0 to pi over 4. And from pi over 4 to pi over 2. Perfect. So we need to compute the area A1 and the area A2. Okay. Are we good? Okay, and then here, the integrand is absolute value of f minus g, and the same thing, f of x minus g of x. Okay? And from the graph, we know that at the interval from 0 to pi over 4, which one is larger? Cosine is larger, very good. Therefore, it will be the g minus f, right? From the interval from pi over 4 to pi over 2, f is larger than g. So it is the difference of this. Very good. Or specifically, it is integral from 0 to 4 of cosine x minus sine x dx plus integral from pi over 4 to pi over 2 of sine x minus cosine x dx, okay? So what should we do now? Yes, we need to find the antiderivative. So what is the antiderivative of cosine? Very good. And the antiderivative of negative sign here? Yeah, cosine. Good job. And it is from x is 0 to pi over 4, right? The second integral, what do we have here? Good job. Negative cosine, and here? Yes, negative sign. Let me just write it pi over 4 to pi over 2, okay? So the first guys becomes sine of, very good, sine of pi over 4. And here is cosine of pi over 4, very good. Then subtract this function at the lower limit, right? Sine of 0 plus cosine of 0. That is the first terms, okay? And the second terms here will be very good. Good job. And good job. Very good. Oh yeah, good job, good job. Thank you. So is it clear? So let us compute it, okay? So remember some special triangle. So sine of pi over 4, it will be Very good. And cosine? Cosine of pi over 4 is also the same things, right? 1 over square root of 2. Okay? Sine of 0? Sine of 0 is 0. Right? Sine of 0 is 0. So it will be this minus 0. Cosine of 0? Yes. Good job. And next here, cosine of pi over 2. Pi over 2 is here. Cosine will be? You see it? At pi over 2 here, we project to the cosine axis, give us at the origin, which is 0. So cosine of pi over 2 is 0. So this is negative 0. And how about sine of pi over 2? 1, yes. Minus 1 here. And here subtract, oh no, yeah. Negative cosine of pi over 4. Very good. And here, sine of pi over 4. Good job. Okay. So therefore, we compute these numbers. So the first sums give us 2 over square root of 2, right? This guy is negative 1. This guy is negative 1, right? And this guy is negative of negative 2 over square root of 2, which negative of negative give us a positive things, right? Let us simplify it. 2 divided by square root of 2 give us square root of 2. 2 is square root of 2 times square root of 2, right? Then here negative 1 and negative 1 give us negative 2. Once again, here is square root of 2. Therefore, it is 2 times square root of 2 minus this. So, is it clear? Okay. Go home and you can try this one. Every step is clear here, right? Go home, you defined. Instead of writing, looking at the graph here, you can write it. Now the function h of x is f x minus g of x. And you do the same things. You find the position where f of x is equal to g of x, or we solve the equation. This is equal to 0. Or it would be sine x minus cosine x is equal to 0. Review how to solve this equation. You will find that the solution of this is pi over 4. And do the same things. Integral from 0 to pi over 4 of f minus g, and you get the same result. Okay? So in general, if you don't have to graph, you can define this function and solve this equation, then you're done. Okay. So, and the last part is if we treat the function as the function x in terms of y, right? Then the idea would be the same. But now it would be the integral from c to d in the y direction. And the function will be the x right. It means the value here. Subtract the x lower. Subtract this. We do the same process. But now the variables is in terms of y. That's it. There's nothing new. Okay? The logic, the idea is the same. Look at this example. Okay? In the second notes I gave you, there is another example here. We are given that y squared is 2x plus 6, and the line y is x minus 1. We see that if we solve in x variable, we need to find the equation of y first, right? We need to define to x positive and negative. It is more complicated. So now if we treat the function as a function of y, f of y, then in the first guy here, in order to get rid of the number 1, we add 1 to both sides. Therefore, we have y plus 1 is equal to x, right? So we define the first line is the line x is equal to y plus 1, or fy is equal to y plus 1 here. The same story here, we write that x will be equal to y squared divided by 2 subtract 3. So we have two lines, x is equal to y plus 1 and x is y squared divided by 2 minus 3. And the same ideas. We define the function fy and gy. We find the solution, the intersection where fy is equal to gy, right? And we study this function. And from this, there are two solutions at y is equal to 4 and y is equal to negative 2. This is a quadratic function. Inside the solution here, we know that it is the opposite sign of the parameter y squared, or it is positive here and negative here. Okay? You just do it by yourself. You see it. Okay, double check it. But then the integral of absolute value of fy minus gy from negative 2 to 4 will be the area of, from y is equal to negative 2 to 4 of, because here f is larger than g, right? Here f is smaller than g. Then the area will be, we remove the absolute value sign and we compute it. We'll have the area of this is 18. That's it. Okay? Go home and double check this one. And I'll see you tomorrow. See you, everybody.